The universe is filled with planets that have no sun. These are rogue planets, drifting alone through the endless night between stars, and they are one of space's most captivating mysteries. By the end of this journey, you will understand how these dark worlds could rewrite the rules of where life can exist. We are diving into 30 astonishing facts about these interstellar nomads, from their violent births to their frozen oceans, and the staggering possibility that they outnumber stars. How does a world survive in total darkness, and what happens when a planet gets kicked out of its solar system? What does it feel like to stand on a world where the sky is forever black? A rogue planet is defined by its profound cosmic solitude. It is a world of planetary mass, but one that is not tethered to any star. It does not orbit a sun. It does not experience years defined by a stellar loop, and its sky is a permanent, star-studded black. Instead of being held in a solar system, these objects travel freely through the vast emptiness between stars, making them true interstellar drifters, completely independent of a star's gravitational embrace. Now, it is crucial to understand what we mean by planetary mass. These are not small rocks or asteroids. They are objects with enough gravity to have pulled themselves into a round shape, just like the planets in our own solar system. They can be gas giants, immense spheres of hydrogen and helium many times larger than Jupiter, or they could potentially be rocky, terrestrial worlds, perhaps even Earth-sized, with mountains, valleys, and frozen cores. This is a key distinction. A rogue planet is not a dwarf planet like Pluto, which still orbits our Sun, nor is it a wandering asteroid. It is a full-fledged world that has been cast adrift, a sovereign entity sailing the galactic sea on its own, answering to no central star. Its journey is one of pure, unguided momentum through the silent dark. The existence of these dark wanderers is no longer a speculative idea. They are not science fiction. Astronomers have confirmed them, and the first undeniable discovery came in 2013. A team, sifting through data from the Pan-STARRS telescope in Hawaii, found a faint, free-floating object in a young star cluster near Beta Pictoris. They named it PSOJ-3 18.5-22. This was a pivotal moment. It was not orbiting a star, it was 6 times the mass of Jupiter, and crucially, it was still glowing with the heat of its violent formation. This young age and residual warmth made it visible, a faint ember against the cosmic dark, proving that planets could indeed be born and then immediately cast out on their own. This discovery opened the floodgates. Since then, we have found more using 2 primary methods. The first is direct imaging, which only works for young, hot rogue planets like PSOJ-3 18.5-22. They glow in infrared light, allowing our telescopes to spot them directly against the blackness. But for the older, colder, and far more numerous rogue planets, we use a different, more subtle technique called gravitational microlensing. Imagine a rogue planet drifting silently between our telescope and a distant star. The planet's gravity, even though we cannot see the planet itself, acts like a tiny lens in space. It bends and magnifies the light from that background star for a brief period, causing the star to appear to brighten in a very specific, telltale way. From that fleeting flash of distorted starlight, astronomers can deduce the mass of the invisible object that caused it, confirming the presence of a dark, drifting world. Through microlensing surveys, the evidence has become overwhelming. Scientists now estimate that for every star in the Milky Way, there could be thousands of these nomads. Our galaxy may be teeming with dark, starless planets, a hidden population far outnumbering the familiar worlds of solar systems. But how does a planet become an orphan? The leading origin story for these wanderers is one of cosmic violence. Most rogue planets are believed to be the casualties of a solar system's chaotic youth. In the swirling disk of gas and dust around a newborn star, planets are coalescing, their orbits unstable and shifting. When two or more massive young planets pass too close, their immense gravitational fields interact like players in a high-stakes game of cosmic billiards. One world can be flung inward, while the other can be slingshot outward with such immense force that it breaks free from its star's gravity entirely. In a single, violent gravitational kick, a planet is ejected, sent hurtling into interstellar space at incredible speeds, becoming a permanent exile. This is not a gentle drift away from home, it is a catastrophic eviction, yet there is another, more serene path to solitude. Some rogue planets may never have had a sun to begin with. In the cold, dense cores of interstellar gas clouds, a small pocket of material can collapse under its own gravity. If it gathers enough mass to become round but not enough to ignite nuclear fusion and become a star, it forms directly as a free-floating planet. These are the true loners, born in the dark and destined to never know a sunrise, more akin to failed stars than ejected refugees. So, the rogue planet population is likely a mix, the violently expelled and the peacefully born alone, all sharing the same eternal night. The speed of these exiled worlds is almost incomprehensible. Once a planet is violently ejected from its solar system, it does not drift lazily away. It is catapulted, becoming one of the fastest natural objects in the galaxy. These rogue planets can achieve velocities of tens or even hundreds of kilometers every single second. To put that into a human perspective, a planet moving at 100 kilometers per second would travel from the Earth to the Moon in little over an hour. Compare that to the stately orbital speeds within our own solar neighborhood. Earth, for instance, orbits the Sun at about 30 kilometers per second. Jupiter, much farther out, moves at a more leisurely 13 kilometers per second. A rogue planet flung free can easily be moving 5 to 10 times faster than that. They are not wanderers, they are cosmic bullets screaming through the void. This blistering speed is a double-edged sword for scientists. On one hand, it is a testament to the incredible forces that shaped their destiny, a permanent scar from the gravitational battle that exiled them. On the other hand, it makes them phenomenally difficult to catch and study. They are moving so fast relative to the background stars that even if we detect one through a microlensing event, it is often gone before we can point other telescopes for a follow-up observation. They are fleeting ghosts in the data, and their journey is not a smooth sail. Traveling at such velocities, they are essentially plowing through the thin gas and dust of the interstellar medium. This creates a bow shock ahead of them, like the wave at the front of a speeding boat, and can slowly erode their atmospheres over billions of years, leaving a faint, turbulent wake in the silent sea of space. They are forever running with the wind of the galaxy itself in their face. This profound darkness is their ultimate cloak, making them nearly invisible to us. The biggest challenge in finding rogue planets is not their distance or their speed, though those are immense hurdles. It is their fundamental nature. They are objects that do not shine. In our own solar system, we see planets because they reflect the brilliant light of our sun. A telescope catches that reflected sunlight bouncing off the cloud tops of Jupiter or the rusty sands of Mars. But a rogue planet has no sun. It drifts through a permanent, starless night with no external source of light to illuminate its surface or atmosphere. To our traditional optical telescopes, which search for visible light, these worlds are utterly black, perfect voids against the slightly less perfect black of deep space. So how do we see the unseen? The answer lies in the faint, dying warmth within. Every rogue planet, especially a young one, retains heat from the violent process of its formation. This residual internal heat, a leftover ember from its birth, slowly radiates away as infrared light. It is an incredibly faint glow, but it is a signature. This is why infrared astronomy is our only window into this hidden population. Telescopes like the Spitzer Space Telescope and most powerfully the James Webb Space Telescope are designed to detect this specific type of heat radiation. They do not look for reflected light. They sense the planet's own feeble thermal heartbeat. The James Webb Space Telescope, with its massive gold-coated mirror and super-cooled instruments, is exquisitely sensitive to these infrared whispers. It can peer into the cold nurseries of young star clusters and potentially spot the faint infrared glow of adolescent rogue planets, worlds still warm enough to betray their presence. For the ancient, frozen wanderers that have bled their heat into space over billions of years, even this fails. They become truly dark, detectable only by the fleeting gravitational lensing effect they have on distant stars. So every discovery is a triumph, a brief glimpse of a shadow passing through an even deeper shadow. This faint gravitational signature is our most powerful tool for finding the smallest and most common wanderers. To detect an Earth-sized rogue planet, we rely on a phenomenon predicted by Einstein's theory of relativity, a cosmic trick of light called gravitational microlensing. Picture a rogue planet drifting silently across our line of sight to a faraway star. The planet's gravity, though invisible, warps the fabric of space around it. As this dark world passes directly between our telescope and that distant pinprick of light, the planet's warped space acts like a magnifying glass. It bends and focuses the star's light rays, causing the star to temporarily appear brighter. This is not a flash or a burst. It is a smooth, symmetrical brightening that can last for a few hours to a couple of days, depending on the mass of the lensing object and its speed. For an Earth-mass rogue planet, the event is incredibly brief and subtle. The star might brighten by just a few percent, a tiny flicker in a vast ocean of data. Astronomers must monitor millions of stars continuously, night after night, searching for these unpredictable and unrepeatable flashes. When they catch one, the shape and duration of the light curve tells a detailed story. From that single, fleeting spike in brightness, they can calculate the invisible object's mass, confirming it is a planet and not a star. They can even estimate its distance. It is forensic astronomy, reconstructing the existence of a dark, frozen world from a single distorted beam of starlight it happened to bend on its endless journey. This method does not require the planet to be young or warm. It can find the ancient, frozen relics that have been drifting for billions of years, completely invisible to any other technique. Each successful detection is a miracle of precision, a momentary alignment across unimaginable distances that reveals a ghost. The sheer number of these dark wanderers is almost impossible to grasp. Gravitational microlensing surveys have painted a startling picture of our galaxy's true population. The data suggests that for every star shining in the Milky Way, there could be thousands of rogue planets drifting in the dark. Think about that scale for a moment. Our galaxy is home to an estimated 100 billion stars. If the most conservative estimates are correct, that implies a hidden ocean of hundreds of billions of rogue planets. But many studies point to numbers far more staggering, suggesting there could be trillions of these starless worlds silently moving between the stars. This means the most common type of planetary body in our entire galaxy might not be an Earth or a Jupiter orbiting a friendly sun. It is far more likely to be a frozen, dark world on a solitary journey through eternal night. This revelation turns our understanding of cosmic architecture on its head. We grew up with the model of orderly solar systems, planets neatly circling a central star. But the universe seems to prefer a different, more chaotic design. It appears that for every planet born into the light of a solar system, countless more are cast out or born directly into the void. These microlensing surveys, which catch the fleeting shadows of these worlds, are like taking a census by listening for footsteps in a pitch-black room. Every time we hear a step, we know another unseen traveler is present. The footsteps are so frequent that scientists now believe these nomads could outnumber every star, every comet, and every asteroid combined. They are the galaxy's silent majority, the true background population of worlds, most of which will never know the warmth of a sunrise. What does it mean for our place in the cosmos if the standard planet is not a member of a solar family, but a solitary, frozen orphan? Their journey is one of relentless, inescapable cold. A rogue planet's ultimate fate is written in the laws of thermodynamics, a slow and irreversible descent into a deep freeze that makes our coldest Antarctic night feel like a tropical beach. Cut off from any external source of heat, these worlds have only one reservoir of warmth, the internal heat left over from their violent formation or from the slow decay of radioactive elements in their cores. And that heat is always inevitably leaking away into the vacuum. Over millions and then billions of years, the temperature plummets, approaching the coldest possible limit in the universe, absolute zero. For a gas giant rogue planet, this cooling triggers a bizarre and beautiful apocalypse. Imagine a world like Jupiter, but untethered from a sun. Its vast, swirling atmosphere of hydrogen and helium is initially warm and turbulent. But as the core cools, the outer layers begin to freeze. Different gases condense at different temperatures. First, the water vapor high in the atmosphere freezes into clouds of tiny ice crystals. Then, as the chill deepens, ammonia might freeze, snowing down into lower layers. Eventually, even the primary components, hydrogen and helium, could undergo a strange transformation. Under immense pressure and extreme cold, hydrogen is predicted to become a metallic liquid, and then potentially even a superfluid, a liquid with zero viscosity that defies our everyday understanding of physics. The atmosphere would slowly rain out, layer by exotic layer, creating a world with a solid core wrapped in oceans of liquid metallic hydrogen, topped with a frozen crust of neon, nitrogen, and other ices. It becomes a layered fossil of its former self. For a smaller, rocky rogue planet, perhaps an Earth-sized world that was ejected, the end state is even more stark. Any atmosphere it once had, whether a thick blanket of carbon dioxide or a thin veil of nitrogen, would freeze solid and collapse onto the surface. The air itself becomes frost. The planet's internal geological activity, driven by heat, would grind to a halt. No more volcanoes, no more tectonic shifts, no magnetic field to shield it from cosmic rays. What remains is an airless, frozen ball of rock and ice, its surface bombarded by radiation and micrometeorites in perpetual silence. Its mountains would stand forever unchanged under a black sky, and any ancient oceans would be locked under ice sheets dozens of kilometers thick, harder than steel. This is the cold, cold reality for a rogue planet, a slow-motion transition from a dynamic world to a silent, frozen monument adrift in the dark. Yet within that deep freeze, a flicker of warmth might persist. A rogue planet is not simply a dead ice cube in space. It carries within its core a source of enduring heat, a faint but vital ember that could sustain extraordinary environments. This internal warmth comes from two main sources. First, there is the residual heat from its violent formation, the leftover energy from the colossal collisions and gravitational compression that built the world. Second, and more long-lasting, is the heat generated by radioactive decay. Elements like uranium, thorium, and potassium, trapped deep within the planet's rocky core, slowly and steadily break down over billions of years, releasing energy as they do. This is the same process that keeps Earth's interior molten and drives our volcanoes and tectonic plates. On a rogue planet, this internal furnace becomes the only source of energy in an otherwise lightless, frigid universe. For a massive gas giant rogue, this heat could create a scenario of astonishing possibility. Picture a world like Jupiter, but alone in the dark. Its immense gravity creates crushing pressures deep within its atmosphere and fluid interior. The heat from its core, unable to escape quickly through the dense layers above, could maintain a vast, stable region of warmth. Scientists speculate that under a global ice shell dozens of kilometers thick, a global ocean of liquid water might exist, kept from freezing by the planet's own internal fire. We see a hint of this right here in our own solar system on Jupiter's moon Europa. Europa is not a rogue planet, it orbits Jupiter, but it is heated internally by the tidal forces of Jupiter's gravity, which stretch and flex its core. That internal heat maintains a global salty ocean beneath its icy crust, an ocean that may contain more liquid water than all of Earth's oceans combined. A rogue gas giant powered by its own radioactive heart could harbor a similar hidden sea, but on a planetary scale. This transforms the concept of a habitable zone. Life on Earth depends on the sun's light, but around a rogue planet, any potential for life would depend entirely on this internal geothermal energy, thriving in perpetual darkness near hydrothermal vents on a subterranean ocean floor, completely isolated from the universe above. That internal heat is not just a geological detail, it is the sole key to any possibility of life in the eternal night. This hidden ocean beneath the ice is not just a theoretical possibility. For a rogue planet, especially a massive one, it could be its defining feature. The key is insulation and an internal heat source. Imagine a world with a rocky core, heated by radioactive decay, surrounded by a deep global ocean, and sealed beneath a crust of ice many kilometers thick. That ice crust is not a weakness, it is a shield. In the vacuum of space, ice is an excellent insulator. It traps the planet's own geothermal warmth inside, preventing it from radiating away too quickly. This creates a stable, dark, liquid ocean, entirely isolated from the frozen surface and the starless sky above. The heat driving this system could come from two places. The first is the planet's own radioactive heart, as we discussed, but there is another, more dynamic source, tidal heating from a moon. Yes, a rogue planet could have its own captured moons. As that moon orbits, its gravitational pull would flex and stretch the planet's interior, generating friction and heat through a constant, gentle kneading. This process is what keeps the oceans of Europa and Enceladus liquid in our own solar system. On a rogue planet, such a moon would be the only source of light in the sky, a faint companion reflecting nothing, but its invisible gravitational embrace could be the engine that sustains a hidden sea. Within that perpetual darkness, a completely alien form of life could arise, one that never knew sunlight. On Earth, almost all life is ultimately powered by the sun through photosynthesis. But at the very bottom of our oceans, around hydrothermal vents, exists an ecosystem that operates on a different principle, chemosynthesis. There, in total darkness under crushing pressure, bacteria use the chemical energy from minerals spewing out of the Earth's crust, like hydrogen sulfide, to create organic matter. They form the base of a food web that includes giant tube worms, blind shrimp, and strange crabs. A rogue planet's subsurface ocean, warmed by geothermal vents on its dark ocean floor, could offer an identical recipe for life. The water provides a medium, the heat from the vents provides energy, the rocky seabed provides the necessary chemicals. It is a closed, dark, warm, and chemically rich environment, perfectly shielded from the lethal radiation and absolute cold of space above the ice. Life here would evolve without eyes, without any concept of day or night, in a world of constant temperature and eternal blackness, sensing its surroundings through pressure, chemistry, and perhaps even electrical fields. The possibility transforms a rogue planet from a frozen tomb into a potential ark, a sealed bottle drifting through the galaxy with a hidden, thriving biosphere inside, completely unaware of the universe beyond its icy ceiling. Life in that hidden ocean would be an exercise in profound patience. In the crushing dark and near-freezing water, energy is the most precious currency, and it is spent with extreme frugality. Any ecosystem that evolved around the geothermal vents on a rogue planet's ocean floor would likely operate on a timescale we can barely comprehend. Organisms might have metabolisms thousands of times slower than anything on Earth. A creature's heartbeat could be measured in days, not seconds. Movement would be a glacial, deliberate process. Growth and reproduction could take centuries. This is life in slow motion, where a single predatory encounter might unfold over the course of a week, and a colony of filter feeders could spend a millennium extending their tendrils a few centimeters closer to a mineral-rich seep. They would be blind, of course, but might sense their world through subtle changes in water chemistry, pressure, or even bioelectric fields. The base of this food web would be chemosynthetic microbes, just like on Earth, but they would process the vent chemicals at an achingly slow rate, supporting a sparse but tenacious web of larger, perhaps gelatinous or shelled creatures adapted to the immense pressure and constant cold. The entire biosphere would be locked in a deep, slow rhythm, dictated by the steady but weak pulse of heat from the planet's core. Its existence would be a whisper in the silence, a testament to life's ability to cling to the faintest ember of energy. And sometimes that internal heat might make a more dramatic appearance on the surface. On such a frozen world, the pressure from the subsurface ocean or from pockets of volatile ices could create cryovolcanoes. Instead of erupting molten rock, these volcanoes would spew water, ammonia, or methane slush. Imagine a geyser of liquid water bursting through the kilometers thick ice crust, instantly freezing into a brilliant, temporary plume of ice crystals against the black sky before collapsing to form a strange, frozen caldera. These eruptions would be rare, catastrophic events from the perspective of the slow life below, potentially delivering new chemicals to the surface or reshaping the icy landscape in fleeting moments of geologic activity. For a brief time, the planet's hidden warmth would touch the absolute cold of space, creating a stunning but sterile monument before the eternal freeze reclaimed it once more. The silence of our solar system's outer frontier may occasionally be broken by a passing shadow. Far beyond the orbit of Neptune, in the frozen realm of the Oort cloud, our sun's gravitational influence grows faint. This vast spherical shell of icy planetesimals is the source of long-period comets, and it is here that a rogue planet could make a silent, unseen visit. Given the staggering number of these dark wanderers in the galaxy, it is statistically likely that one has drifted through our Oort cloud in the distant past, or will do so in the distant future. The encounter would be a ghostly one. The rogue planet, moving at tremendous speed, would not collide with anything in that sparse region. Instead, its gravity would be the disruptive force, acting like a subtle hand stirring a cloud of dust. As it passed through, its gravitational pull would perturb the delicate orbits of countless icy bodies. Some of those comets, nudged from their stable paths, could be sent on new trajectories, falling inward toward the sun. This could trigger a shower of comets into the inner solar system, a celestial storm that would light up our skies with new visitors over thousands of years. On a more dramatic and far less probable scale, a rogue planet passing unusually close to the planetary zone could theoretically cause chaos. Its gravity could tug on the orbits of the planets, potentially destabilizing them. The probability of such a close, disruptive encounter is vanishingly small, almost zero, when you consider the incomprehensible emptiness of space. The distances between stars and their wandering planets are so vast that close passes are astronomically rare events. Yet, the mere possibility reminds us that our solar system is not an isolated island. It exists within a dynamic galactic environment, occasionally brushed by the unseen currents of interstellar space, where dark nomads pass by like ships in the cosmic night, their influence felt only in the subtle rearrangement of ancient ice. This cosmic solitude might not always be absolute. A rogue planet could travel with its own tiny, dark solar system. When a planet is violently ejected from its home star, the gravitational chaos does not necessarily strip away its moon. If a moon is orbiting close enough and the ejection is a clean, swift kick, the entire system can be flung into the void together. So picture this not as a single wanderer, but as a nomadic family. A dark, frozen planet, perhaps a gas giant, drifts through the interstellar night, and circling it is a moon, or even a collection of moons. their surfaces lit only by the faint glow of the planet's auroras or the reflected light of distant stars. They are a closed, miniature cosmos bound by gravity but utterly free from any sun. This companionship is more than just a poignant image. It could be the key to turning a frozen world into a potentially habitable one. A large moon, like a scaled-up version of Jupiter's Europa or Saturn's Enceladus, would exert a constant gravitational pull on its host planet. As it orbits, that pull flexes and stretches the planet's interior, creating friction. This friction generates heat, a process we call tidal heating. In our solar system, tidal heating from Jupiter is what keeps the subsurface ocean of Europa liquid. For a rogue planet, a loyal moon becomes an internal furnace. The moon's gravity tirelessly kneads the planet's core, pumping geothermal energy into the system long after the planet's own radioactive heat begins to fade. This external energy source could maintain a stable, warm subsurface ocean for billions of years longer than the planet could manage on its own. The moon itself, if it is icy, might also be warmed by this reciprocal tidal tug, potentially harboring its own hidden sea. So you have a pair of worlds, a dark planet and its moon, drifting forever through the void, each keeping the other warm through their gravitational embrace. They are a self-contained biosphere, a double world where life might arise in the deep, dark oceans of either body, sustained not by starlight, but by the silent, constant dance of their orbits. It is a lonely journey, but perhaps not a lonely existence. But the story of a rogue planet does not always end in eternal solitude. While ejection is a violent farewell, the cosmos offers a rare second chance, a gravitational embrace called capture. If a starless wanderer drifts close enough to a functioning solar system, the star's gravity can reach out and seize it, pulling the orphan into a new, chaotic family. This is not a gentle adoption. The captured planet does not slip into a neat, circular orbit like the native worlds. Instead, it is snagged on the fly, resulting in a wildly eccentric and often highly inclined path. Imagine a new planet entering the system at a steep angle, swinging incredibly close to the star at blistering speeds before hurtling back out to the distant frozen reaches, a comet on planetary steroids. This capture theory provides a compelling explanation for some of the strangest exoplanets we have ever found. Astronomers have discovered gas giants orbiting their stars in bizarre, tilted paths, or following such elongated orbits that they spend most of their time in the deep freeze, only to scorch briefly near their sun. These planets are misfits in their own systems, their orbits misaligned with the star's spin and the orbital plane of the other planets. The most logical explanation is that they were not born there. They are captured interlopers, rogue planets that were passing by and got caught in a stellar net, forever marking them as outsiders with their strange, looping dance. Their presence is a permanent record of a long-ago encounter, a cosmic accident frozen in orbital mechanics. Our own galaxy's hidden population is just the beginning. The phenomenon of rogue planets is a universal one, stretching far beyond the borders of the Milky Way. Astronomers have detected the first compelling evidence of a starless world in another galaxy entirely. This candidate was found not by seeing it, but through the same gravitational microlensing technique we use locally. A distant star in another galaxy briefly brightened in a signature way, and the lensing object's calculated mass was too small to be a star, pointing instead to a planetary mass wanderer drifting in the intergalactic void. This single event, though still awaiting definitive confirmation, is a revelation. It tells us that wherever stars form and solar systems coalesce, planets are also cast adrift. The process is a fundamental part of cosmic evolution, happening in every spiral, elliptical, and irregular galaxy across the observable universe. And if that is true, the numbers become truly mind-numbing. Consider all the stars in all the galaxies. There are estimated to be 2 trillion galaxies, each with billions of stars, and potentially thousands of rogue planets for each star. The cumulative total of these dark wanderers across the cosmos could be a number so large it defies meaningful analogy. One attempt is to compare it to all the grains of sand on every beach and in every desert on Earth. The estimated count of sand grains on our planet is about 7.5 times 10 to the 18th power, or 7.5 quintillion. The number of rogue planets in the universe could be thousands, even millions of times greater than that. Every single speck of sand on our entire world might represent just one of countless trillions of these frozen orphans sailing the dark currents between galaxies. They are not merely a local mystery, but the most common type of world in existence, the silent foundation of the cosmic architecture. This distinction between worlds is crucial yet blurry. Where exactly do we draw the line between a rogue planet and something else entirely? The answer lies in a cosmic boundary defined not by light but by mass. On one side, we have the rogue planets we have been discussing. On the other, we have objects known as brown dwarfs, often called failed stars. The key difference is what happens inside them. A brown dwarf forms just like a star from the collapse of a gas cloud, but it simply does not gather enough mass to ignite the sustained nuclear fusion that powers stars like our Sun. It is an object stuck in a permanent state of almost stardom. The dividing line is remarkably precise. Astronomers define it at about 13 times the mass of Jupiter. Any free-floating object below that threshold is classified as a planetary mass object, a rogue planet. Any object above 13 Jupiter masses crosses into brown dwarf territory. Why that specific number? Because at that mass, the internal pressure and temperature become sufficient for a brief cosmic moment to fuse a rare heavy isotope of hydrogen called deuterium. This deuterium burning is a faint, short-lived flicker compared to the Sun's mighty fusion engine, but it is enough to separate the planets from the failed stars. So, a rogue gas giant with 12 times Jupiter's mass is a planet, drifting cold and dark. An object with 15 times Jupiter's mass is a brown dwarf, born hot and glowing dimly from its own internal deuterium fire before eventually cooling into a similar state of darkness. This means some of the faint, free-floating objects we detect, especially the young, warm ones, are actually these smallest brown dwarfs, not planets. They are the heavier siblings in the family of interstellar orphans, and among them are the coldest known objects of all, a class called white dwarfs. These are ancient brown dwarfs that have radiated away all their formation and deuterium-burning heat. Their temperatures can plunge to a level comparable to a cold winter day on Earth or even lower. They are so frigid that water vapor in their atmospheres freezes into clouds of ice crystals. Finding these white dwarfs is an immense challenge as they emit almost no light or heat, appearing only as the faintest of infrared whispers against the void. They represent the ultimate convergence where the coldest failed stars and the most massive rogue planets become nearly indistinguishable, both ending their long lives as dark, frozen wanderers in the endless night. The hunt for these cosmic orphans is about to enter an unprecedented new era. We have a new tool in the darkness, one with vision powerful enough to see the faintest embers of warmth against the void. The James Webb Space Telescope is not just another observatory. It is a revolutionary eye tuned to the infrared spectrum, the exact type of light that rogue planets emit as they cool. Its massive gold-coated mirror collects more of this faint glow than any telescope before it, and its super-chilled instruments operate at temperatures just a few degrees above absolute zero, making them exquisitely sensitive. This combination allows Webb to do what was previously impossible, directly image rogue planets that are not just the blazing hot young ones, but also cooler, older objects that have faded into near invisibility. It can peel back the darkness and study them not just as statistical blips, but as real worlds with atmospheres and compositions. Astronomers have already designed ambitious programs specifically for this purpose. One key project will stare into young star-forming regions, the nurseries where planets are born and often violently evicted. In these chaotic clouds, Webb will search for the faint, isolated infrared pinpricks of adolescent rogue planets, worlds still glowing with the heat of their formation. By finding them here, scientists can directly test the ejection theory, understanding exactly how and when planets get kicked out of their systems. Another program will use its spectroscopic capabilities on any rogue planets it finds. Spectroscopy is like taking a cosmic fingerprint. When the faint infrared light from a rogue planet passes through Webb's instruments, it gets split into a spectrum. Dark lines in that spectrum reveal the specific chemicals present in the planet's atmosphere, whether it is methane, water vapor, ammonia, or carbon monoxide. For the first time, we will not just know a rogue planet is there, we will know what it is made of. Is it a hydrogen-rich gas giant or a world with a thicker, more complex atmosphere? Does it show signs of weather or clouds in its eternal night? Each answer will transform these phantoms from theoretical concepts into tangible, characterized worlds. Webb's mission promises to move us from simply counting shadows to finally studying the shadows themselves, mapping the architecture of the dark. The language we use to describe them is as varied as their origins. Astronomers, faced with such a mysterious and evocative class of objects, have not settled on just one name. Each term paints a slightly different picture of these dark wanderers. The most popular is undoubtedly Rogue Planet. It carries a sense of danger and lawlessness, a cosmic rebel that has broken free from the orderly system. It is a name full of drama. Then there is Free Floating Planet, which is more clinical and descriptive, focusing on its state of motion rather than its character. Interstellar Planet highlights its domain, forever traveling between the stars. Some prefer Nomad Planet, evoking a sense of endless, purposeful wandering across the galactic planes. And perhaps the most poignant is Orphan Planet, a term that underscores the loss and solitude, a world cast out from its stellar family. All of these are used interchangeably in science articles and documentaries, each bringing its own flavor to the story. But if you want the official, technical term from the International Astronomical Union, the body that names celestial objects, you would say Free Floating Planetary Mass Object. It is a precise mouthful that leaves no room for poetry, clearly defining it as an object with planetary mass that is not bound to a star. This playful naming convention is a tradition in astronomy. When we discover something new and baffling, we reach for metaphors that help us grasp its nature. We have pulsars for spinning neutron stars that pulse like cosmic lighthouses, black holes for gravitational pits from which nothing escapes, and dark matter for the invisible glue holding galaxies together. The many names for these planets reflect our attempt to understand their story, to categorize the uncategorizable. Whether you call it a rogue, a nomad, or an orphan, the name captures a fundamental truth about its existence, a world forever untethered, writing its own lonely story against the dark. The sheer number of these dark wanderers naturally leads to a dramatic question. Could a rogue planet ever collide with Earth, a cosmic catastrophe from the silent dark? This is a favorite doomsday scenario in science fiction, but the reality is a profound lesson in the scale and emptiness of space. The probability is so infinitesimally small that it borders on the impossible. To understand why, we must first grasp the true distances involved. The stars are not close neighbors. They are isolated islands separated by an ocean of near-nothingness. The closest star to our Sun, Proxima Centauri, is about 4.2 light-years away. That is not just a large number. It means that traveling at the speed of light, the absolute fastest speed possible in the universe, it would still take over 4 years to reach it. The space between stars is almost incomprehensibly vast, and rogue planets drift through that immense void. Now consider the size of a planet, even a gas giant like Jupiter. It is a speck, an absolute speck compared to the volume of space it travels through. It is like trying to hit a single, specific grain of sand floating somewhere in all the oceans of Earth while you are blindfolded and standing on the shore. A more vivid analogy might be firing a bullet from New York City and hoping to hit a single, particular coin that has been placed on a sidewalk in Tokyo. The bullet would have to travel thousands of miles and land on that one tiny, specific spot, missing every other building, car, and person in between. That is the scale of the challenge for a rogue planet aiming for Earth. The distances are millions of times greater, and the targets are millions of times smaller. Even with trillions of rogue planets in the galaxy, space is so overwhelmingly empty that close encounters between stellar systems are rare, and direct collisions are so statistically negligible they are not a realistic concern for our world. The real hazard is not from a collision, but from a very, very distant gravitational nudge, as we discussed earlier, which could subtly stir comets in our distant Oort cloud over eons. So, while the idea makes for thrilling fiction, we can rest assured that our planet is safe from this particular shadow in the night. The true story of rogue planets is not one of destruction, but of silent, frozen wonder drifting in the magnificent emptiness between the stars. The sudden appearance of a true interstellar visitor shattered a long-held assumption about our cosmic neighborhood. In October 2017, a telescope in Hawaii spotted a faint, fast-moving point of light that did not belong to our solar system. It was named Oumuamua, a Hawaiian word meaning scout or messenger from the distant past. This was not a comet or asteroid from our own backyard. Its extreme speed and trajectory proved it was an object from another star system, the first one ever observed passing through ours. While Oumuamua was small, likely less than a kilometer long, its visit was a monumental discovery. It proved that interstellar space is not empty, but filled with wandering debris, the cosmic flotsam and jetsam ejected from other solar systems. Its strange, elongated shape and unexpected acceleration sparked intense debate and wild theories, but its fundamental lesson was clear. The walls of our solar system are porous. Things from out there can and do come in. Now, imagine if the visitor was not a speck of rock but a world. If a rogue planet, a dark sphere thousands of times more massive than Oumuamua, were to make a similar passage through our solar system, the event would be of a completely different magnitude. Unlike the tiny, faint Oumuamua, which we only noticed as it was already speeding away, a rogue planet's influence would be gravitational, not visual. We would likely detect it not by seeing it, but by feeling its pull. Its immense gravity would act like a silent tremor in the fabric of our solar system. The orbits of distant objects in the Kuiper belt and Oort cloud would be subtly perturbed, wobbling in ways that would baffle astronomers. Comets might be stirred from their icy slumber in unexpected numbers. The outer planets themselves, especially Neptune and Uranus, might exhibit tiny, unexplained deviations in their paths around the Sun. By the time we pieced together the clues and realized a massive, invisible object was passing through, it would probably already be on its way out, a dark ghost that had already shaken our celestial neighborhood. We would be left with a mystery written in the rearranged orbits of distant ice, a signature of a world that came and went without ever showing its face. The visit of Oumuamua was a whisper from the galaxy. The passage of a rogue planet would be a shout felt in the bones of our solar system long after the source had vanished back into the dark. The absolute darkness is the least of its worries. A rogue planet's journey through the galaxy is a constant, silent bombardment. Stripped of the most fundamental protection a star provides, it sails naked into a storm of invisible bullets. Our own sun creates a vast protective bubble called the heliosphere. This is a region of space dominated by the solar wind, a stream of charged particles that pushes against the incoming chaos of the galaxy. The heliosphere acts as a cosmic shield, deflecting and slowing many of the high-energy particles that scream through interstellar space. But a rogue planet has no sun and therefore no heliosphere. It is utterly exposed. What hits it is the full, unfiltered fury of galactic cosmic rays. These are not rays of light. They are atomic nuclei, mostly protons, that have been accelerated to nearly the speed of light by supernova explosions and other violent events. They carry immense energy, enough to shred complex molecules and damage living tissue at a cellular level. For any hypothetical life clinging to a rogue planet, this radiation is an existential threat. It would rain down relentlessly on the surface, sterilizing it completely, breaking down any organic compounds and turning the frozen crust into a radioactive wasteland. The sky may be black, but it is never truly quiet. It is filled with this deadly, silent sleet. This harsh reality makes the idea of a subsurface ocean even more critical. The planet's thick global ice shell, perhaps dozens of kilometers deep, becomes more than just an insulator. It transforms into a life-saving bunker. That ice is a phenomenal radiation shield. Just as meters of concrete protect workers in a nuclear reactor, kilometers of water ice would absorb and block the vast majority of cosmic rays. Any potential ecosystem in the dark ocean below would be safely cocooned, living in a sanctuary of liquid water and geothermal warmth, completely isolated from the lethal environment above. The radiation bath is so intense that it might even leave a detectable signature. Over eons, the constant bombardment could alter the chemistry of the surface ice, creating exotic molecules or isotopes that future telescopes from a safe distance might one day recognize as the scar of a world that has traveled too long in the dark. This profound darkness makes them perfect candidates for a cosmic mystery. Among the wildest theories in astronomy is a simple, startling idea. Could rogue planets be the elusive dark matter? Dark matter is the invisible, mysterious substance that makes up about 85% of the universe's mass. We cannot see it, but we know it is there because its immense gravity holds galaxies together, preventing them from flying apart as they spin. For decades, scientists have searched for what this missing mass could be. One early, tempting thought was that it might be made of massive, compact objects hiding in the dark, objects exactly like rogue planets. They are massive, they are dark, and they are everywhere. It is a beautifully simple solution, but science, through careful observation and calculation, has ruled it out. The combined mass of all the rogue planets in the galaxy, even if they number in the trillions, is simply not enough. When astronomers add up all the possible mass from these wandering worlds, it accounts for only a tiny, tiny fraction of the gravitational glue needed to bind a galaxy. Rogue planets, for all their strangeness, are made of the same ordinary stuff as you, me, and the stars. They are baryonic matter composed of protons, neutrons, and electrons. Dark matter appears to be something entirely different, a form of matter that does not interact with light or normal matter in any way except through gravity. So while rogue planets add to the hidden mass of the galaxy, weaving through the spaces between stars, they are not the ultimate secret. They are a fascinating piece of the cosmic puzzle, but the greater shadow, the true dark matter, remains something else entirely, a deeper and more profound enigma waiting to be solved. That radiation-soaked surface might hold a different kind of treasure for a future not our own. For a civilization mastering interstellar travel, a rogue planet is not a dead end, it is a cosmic oasis. Think of the galaxy as a vast, empty ocean, and stars as islands separated by unimaginable gulfs. A starship traveling between them would need resources, fuel, and places to rest. A rogue planet drifting in that emptiness becomes a perfect hidden-way station. It offers raw materials in staggering abundance. Its frozen crust could be mined for water ice, a precious commodity in space, providing not just drinking water, but also the hydrogen and oxygen for rocket fuel and air. Its rocky mantle and metallic core could yield minerals and rare elements difficult to find in the thin dust between stars. A sufficiently advanced culture might not just visit these worlds, they might transform them. Imagine converting an entire rogue planet into a generation ship, a concept taken to its ultimate scale. The planet itself becomes the vessel. Using its own internal geothermal heat as a power source, a civilization could burrow into the insulating ice, creating vast, shielded cities within the global ocean or the rocky mantle. They would have a stable, self-contained ecosystem with virtually limitless resources for a journey lasting millions of years. The planet's immense mass provides gravity and protection, while its momentum carries the entire civilization silently toward a distant star cluster. It is the ultimate arc, turning a cosmic orphan into a cradle for life, purposefully steering it through the dark. Their story is written in the fading warmth of their cores. A rogue planet can be any age, from a cosmic infant just moments after its violent ejection to an ancient relic drifting since the galaxy's fiery youth. Unlike stars, whose age we can estimate by their color and brightness on the main sequence, a rogue planet's age is etched into its temperature. It is a simple, profound clock. When a planet is first cast adrift, it glows with the searing heat of its formation, a bright ember in the infrared sky. Over time, that internal heat radiates relentlessly into space and the world cools. The rate of this cooling is not random. It follows the laws of physics governed by the planet's mass, composition, and initial temperature. A massive gas giant with its immense volume to retain heat will cool far more slowly than a small, rocky world. By carefully measuring the faint infrared glow of a rogue planet we can directly image, astronomers can take its temperature. From that single data point, they can run the cooling models backward, estimating how long it has been since that world was born or ejected. It is like touching a stone pulled from a fire and guessing how many hours have passed since the flames died. The youngest rogue planets are the easiest to spot, their warmth making them visible against the cold backdrop. They are the newcomers to the interstellar dark, still holding the memory of a star's light. But the true phantoms are the old ones. After billions of years of cooling, a rogue planet's internal heat fades to a whisper. Its temperature plummets toward that of the cosmic microwave background, the faint afterglow of the Big Bang itself. These ancient wanderers are the coldest, darkest objects of planetary mass in existence. They are more than just old. They are cosmic fossils, pristine time capsules from an era when the galaxy was young. Formed in the first few billion years after the Big Bang, they have been drifting, untouched and unaltered by stellar radiation for eons. Their composition is a frozen record of the primordial gas clouds from which they condensed, holding chemical secrets about how planets built themselves in the universe's chaotic early days. Finding and studying one of these ancient relics would be like discovering a perfectly preserved dinosaur bone, not in rock, but sailing silently through the void, carrying the unspoiled blueprint of planetary birth from a time before our sun even ignited. The chaotic youth of a solar system plays out like a game of musical chairs on a galactic scale. Imagine the swirling disk of dust and gas around a newborn star as the game board. The forming planets are the eager, jostling players, their masses creating powerful gravitational pulls. For millions of years, the music plays. This is the dynamic, unstable period of the system's formation, with orbits shifting and crossing. The young worlds move inward and outward, sometimes passing dangerously close. Their gravity tugs and pulls in a complex dance, a celestial version of players circling the chairs. Then, as the system begins to settle, the music starts to fade. The gas disk dissipates and the most stable orbital configurations begin to lock in. This is the moment the music stops. In that final, critical instant, every planet scrambles for a stable, long-term orbit, a chair. But in this high-stakes game, there are not enough stable chairs for all the players. The gravitational interactions are so intense that one planet, usually a smaller or more precariously placed world, can be slingshot with tremendous force. It is flung clear across the room, not just to the edge of the game, but out the door entirely. It loses its chair, its place in the system, and is ejected into the interstellar void, becoming a permanent spectator to the game it once played. This analogy makes a violent, abstract process wonderfully clear. The ejected planet is not necessarily the smallest or the weakest. Sometimes it is simply the one caught in the wrong place during the final gravitational crescendo, a victim of bad timing in a cosmic rearrangement that lasts for eons. Einstein's theory of relativity offers a tool hidden within the darkness. A rogue planet's immense gravity warps space so dramatically that it can bend and focus light, acting like a natural cosmic magnifying glass. This phenomenon, called gravitational lensing, is the same principle that lets us detect these dark worlds, but astronomers propose we could flip the script. Imagine not just detecting the lens, but using it. The idea is breathtaking in its ambition. A precisely positioned spacecraft could use a rogue planet as the ultimate telescope. By maneuvering to a specific point along the line of sight directly behind the planet, the spacecraft would sit in the focal region where the planet's gravity gathers and amplifies the light from a distant object behind it. This is not a small boost. The magnification could be millions of times more powerful than any telescope we have ever built, turning a faint smudge of a galaxy into a detailed image, or resolving the surface features of an exoplanet orbiting a star hundreds of light years away. It would be like turning the entire planet into the primary mirror of an observatory, one with a diameter measured in thousands of kilometers. The technical challenges are, of course, monumental. We would need to know the exact mass and position of the rogue planet, calculate the perfect focal line that stretches for billions of kilometers behind it, and then send a probe on a journey that could take centuries to reach that exact spot. But the scientific payoff would be a window into the universe unlike any other, a chance to see the cosmos through the silent, focused eye of a dark wanderer. The sky is a perfect, unbroken black, a void deeper than any earthly night. On the surface of a rogue planet, the sun never rises. There is no dawn to paint the clouds, no midday glare, no golden hour to cast long shadows. Time, as we measure it in days and seasons, ceases to have meaning. The only light comes from above, if you can call it light at all. If the world is airless or possesses a crystal-clear, frozen atmosphere, the view is one of terrifying clarity. The Milky Way does not twinkle. It is a vast, frozen river of dust and diamond-hard stars, a brilliant scar across the infinite dark, so vivid it feels close enough to touch. There are no clouds to soften it, no atmospheric haze to dim its glory. It is a panoramic, silent scream of light in an ocean of nothingness. If a thin atmosphere persists, it might create a faint, permanent aurora, a shimmering curtain of green or red driven by the planet's magnetic field and the bombardment of cosmic rays, the only source of color in an otherwise monochrome existence. The ground beneath your feet, if you could stand there, would be a landscape of eternal freeze. Mountains of water ice, hard as granite, carved jagged silhouettes against the stellar backdrop. Plains of frozen nitrogen or methane stretch to a horizon that feels unnervingly close in the stark, shadowless light. There is no wind to speak of, for the atmosphere is either gone or has settled into a deathly stillness. The only sounds would be geological, felt more than heard, a deep, subsonic groan from a shifting glacier of ice or a distant rumble as a cry of volcano prepares to erupt. And sometimes it might snow, but this is no gentle flurry. In an atmosphere of nitrogen or methane, the snow would be exotic crystals, falling in absolute silence, accumulating over millennia into drifts that never melt. It is a world of profound sensory deprivation, where sight is reduced to the static map of the galaxy and sound is the memory of your own heartbeat. This is not merely solitude. It is the absolute quiet of a finished story, a world that has settled into its final, frozen form, bearing witness only to the slow march of the stars across a sky that will never change. The galaxy's true population is a silent one, For every star like our Sun shining brightly in the void, there might be 100,000 rogue planets drifting unseen in the dark. Let that number truly sink in. That is not a handful or even a few thousand. It is an ocean of darkness for every single point of light. This simple, staggering statistic flips our entire understanding of cosmic architecture on its head. We grew up with a model of the universe centered on solar systems, with planets neatly orbiting their parent stars in a stable, familiar dance. But the data from gravitational microlensing surveys tells a very different story. It suggests that the orderly, sunlit worlds like our own may be the cosmic exception, not the rule. The standard planet in the Milky Way is not an Earth or a Jupiter basking in stellar warmth. It is far more likely to be a frozen, solitary wanderer, a sovereign world sailing the interstellar sea without a sun, without a day, and without a year. The galaxy, then, is not primarily a collection of stellar systems with occasional empty spaces between them. It is better imagined as a vast, three-dimensional swarm of dark, planetary mass objects, through which the stars and their attendant planets move like rare, brilliant ships crossing a dark, choppy ocean. This hidden majority rewrites the narrative of what a planet is. Our search for life, for resources, for understanding has been fixated on the light. But the true background of the cosmos, its most common form of planetary mass, exists in the permanent shadow. What does it mean for our place in the universe if we are the rare inhabitants of a rare type of world, orbiting a rare star, while the galaxy teems with countless dark, frozen counterparts? It means the story of planets is not a story of families gathered around a hearth. It is a story of exiles, of loners born in the dark, outnumbering everything else by orders of magnitude. They are the true citizens of the galaxy, and we are the fortunate few living in the light. This pristine isolation makes them the ultimate cosmic time capsules. Unlike planets orbiting active stars, which are constantly reshaped by solar winds, radiation, and gravitational tides, a rogue planet is sealed away in a perfect vault of darkness. Once it leaves its star or forms alone, its surface and interior are shielded from almost all external forces that could alter its original state. There is no stellar wind to erode its atmosphere over eons, no relentless light to bake and chemically change its surface ices. It simply cools and drifts, its geological story pausing, its composition locked in time from the moment of its exile. For a world ejected in the chaotic youth of its solar system, this means its very substance is a frozen snapshot of that early era. Its atmosphere, if it retains one, holds the exact mix of gases present when planets were still coalescing from the protoplanetary disk. Its crust contains minerals and ices in their primordial state, untouched by billions of years of weathering or biological activity. To study such a world up close would be an archaeologist's dream on a cosmic scale. It would be like opening a letter written 4 billion years ago, a message in a bottle from the early universe that details the original recipe for building planets. Every layer of its ice, every gas in its thin, frozen air, every isotope in its rocky core would be a data point from a time before our own sun ignited. Scientists could analyze the ratios of rare elements, look for complex organic molecules that formed in the cold dark, and test theories about how the building blocks of life are scattered across the galaxy. These dark wanderers are not just orphans, they are silent historians, carrying within them an unread record of the galaxy's fiery, formative years, waiting in the freezer of deep space for someone someday to learn how to read their story. Our search for these dark wanderers has only just scratched the surface of the void. Every fact we have explored, from their violent births to their frozen oceans, represents the first whispers of a story we are only beginning to hear. The truth is, our map of the galaxy is still drawn almost entirely in light. We have charted the stars, but the spaces between them remain vast, uncharted territories where countless rogue planets drift unseen. This is not the end of the mystery, it is the opening chapter. The next generation of telescopes and space missions is being designed with these specific shadows in mind. Upcoming observatories like the Nancy Grace Roman Space Telescope will conduct microlensing surveys of unprecedented scale, scanning the galactic core to catch the fleeting distortions caused by thousands, perhaps millions, of these invisible worlds. Each flash of bent starlight will be a data point, slowly filling in the census of our galaxy's true dark population. And the James Webb Space Telescope, with its infrared eyes, will continue to stare into stellar nurseries, hoping to catch the faint glow of young rogues as they are first cast into the dark. With every new instrument, our vision improves. We are learning to see in the dark. One profound possibility hangs in the balance of this search. Statistical models suggest that the nearest rogue planet to our solar system could be closer than the nearest star. While Proxima Centauri is 4.2 light-years away, a dark, frozen world might be drifting silently just 2 or even 1.5 light-years from us, a next-door neighbor we have never noticed because it gives off no light. It would be a member of our immediate cosmic community, yet completely invisible to us, a hidden companion in our journey around the galaxy. Finding such a nearby rogue planet would change everything. It would transform it from a statistical probability into a tangible world, a destination. While still an immense journey by any human measure, its proximity would make it the first interstellar object we could realistically consider for a robotic probe, a mission that would take decades instead of millennia. We could send our sensors to directly taste its frozen atmosphere, measure the thickness of its ice, and listen for the groan of its interior. The next great discovery in astronomy might not be a new exoplanet orbiting a distant sun. It could be a cold, dark world revealed right in our own stellar backyard, a reminder that the universe's greatest secrets are often hidden in plain sight, or rather in plain darkness. Each new rogue planet we find challenges our definitions. What is a planet if the most common ones have no sun? What is a solar system if planets can exist perfectly well outside of them? And most profoundly, what is life if it can potentially thrive in the warm, radioactive dark beneath the ice of a world that has never known a sunrise? The search continues, not just for more worlds, but for answers to these deeper questions. The dark is not empty. It is full of possibilities, waiting for our light of inquiry to finally reach them. Our galaxy's true nature is one of profound and silent darkness. The most astonishing takeaway from this journey is not that rogue planets exist, but that they are the standard. For every star you see in the night sky, there could be 100,000 of these dark, starless worlds drifting unseen. The universe is not primarily a collection of solar systems. It is a vast, three-dimensional sea of frozen wanderers, and we, orbiting our sun, are the rare exception living in a temporary pool of light. These nomads are not dead relics. They are dynamic worlds with their own hidden stories, powered by the faint, radioactive heartbeat of their cores. That internal warmth carves out possibilities in the eternal freeze, maintaining global oceans beneath ice shields kilometers thick, where life could theoretically take root in total darkness, sustained by chemistry and geothermal vents, never knowing a sunrise. They are also pristine cosmic fossils. Each one is a frozen time capsule, its composition locked from the moment of its violent birth or serene formation, holding unspoiled secrets about how planets are built from the raw stuff of the galaxy. This reshapes our search for life and our understanding of what a planet even is. The humbling truth is that if life is out there, it may not be basking under a friendly sun on a world like ours. It might be thriving in the warm, radioactive dark under the ice of a world that has never known a day, on a journey that will never end. The cosmos is far stranger and more inventive than we ever dreamed. Which of these 30 facts about rogue planets left you the most amazed? Was it their staggering numbers, their hidden oceans, or the idea that the nearest one could be drifting right in our stellar backyard? Let us know in the comments below and subscribe to join us as we continue exploring the deepest mysteries of space, one dark wonder at a time.